at the rational function, how we can find the increasing and decreasing intervals for it. So in here in question 17, if we would like to find the increasing and decreasing intervals, so starting with, okay, so let's solve question 17, that's fine. Okay, so in here, first of all, the domain, it will be, since we have rational function, so it will be r minus the zeros of the denominator. Now, the zeros of the denominator, in here, I will take the denominator aside, 1 plus x cubed. Okay, let's make it equal to 0. So I'll take minus 1 over here. So x cubed equal to minus 1. Then I will take cubic root. Okay, so x is equal to minus 1. So in here, I will say I have the domain which is r minus 1 only. Okay, so now starting with finding the derivative, in here the denominator multiplied by the derivative of the numerator which is 1 minus the numerator x multiplied by the derivative of the denominator which is 3x square, okay, divided by the denominator square. Let's simplify it a little bit. So this is going to be equal to 1 plus x cubed minus x multiplied by 3x squared. This is a 3x cubed over 1 plus x cubed square. So 1 plus x cubed minus 3x cubed, which is minus 2x cubed. So divided by 1 plus x cubed square. Now let's make the derivative equal to 0 from the numerator, zeros. So in here, 1 minus 2x cubed equals 0. So this is going to be 1, take the 2x cubed to this side, then divide by 2. So it will be x is equal to cubic root of cubic root. Yes, of 1 over 2, which is 1 over the cubic root of 2. Okay, now for the denominator, it will be over here 1. Okay, so undefined value, which is 1 plus x cubed equals 0, and this is going to give me x is equal to, after taking the minus 1 at the cubic root, this is equal to minus 1. So this is minus 1. Okay, so I will reject this value since it's not included in my domain, and I will take this value since it's included in my domain as a critical number. So let's do the test, the number line test. So directly 1 over cubic root 2. So I will take value to the right and I will take value to the left and substitute it in the derivative. Let's just find 1. Okay, so 1 over the cubic root of 3 or 2 in here. So this is equal to what? This is 0.79, which is almost 0.8. So I'll take value to the right and substitute it in the function. So 1 minus, of course, I'm not substituting in the original function, I'm substituting in the derivative. So alpha x cubed, okay, so over in here, open parentheses, 1 plus x cubed. So this is a cubed. I think it's a cube. Okay. Square, all square. Okay, last all square. Yes, so calculate at a value greater than, let's take 6. Okay, this is negative. Let's calculate value less than. I will take minus 3, for example. Okay, or okay, minus 3, it will be less than. Just a second. I'll take 0. Okay, this is positive. Now you remember that we said even if it's not included, I will take it not as a critical number, but I'll put it on the number line. That's fine. So in here I took the 0, it was positive, and in here it was negative. And here the minus 1 is not included. Okay, so if we take, for example, a value, okay, keep this, a value less than minus 1, so calculate at minus 3, will be positive. So this is positive. Okay, so the function is increasing from minus infinity to minus 1 union with minus 1 to infinity, to not infinity, to 1 over cubic root of 3. Okay, so 1 over cubic root of 2. Okay, and the function is decreasing from 1 over cubic root of 2 to infinity. Critical number, I have 1 over cubic root of 2 as a critical number only. The minus 1 is not a critical number because it's not included in my original domain. Okay, so next inshallah we will talk about finding the increasing and decreasing intervals for square root of x cubed plus 3x squared.